Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So I'm Muhammad Rakwan Roslan as a presenter one. So we are from Crude Time, our project based on chapter 2, static of particle. Hi. So for a second slide, I will introduce our group members. So first of all, first presenter, me, I'm Roslan, matrix number CD240348. Second presenter, Ali Farhan, CD240329. Third presenter, Wafid Zai, matric numbers CD240386. Fourth presenter, Nixon, CD240338. Last presenter, Faiz Rustam, CD240354. Hi guys, welcome back. You guys still with me. First presenter, I'm Roslan. So, for next slide, I will share about introduction. So a particle is in equilibrium when the sum of all external force acting on it is zero. So means sum of F equals to zero. So meaning it is either at rest or moving at constant velocity. So force acting on a particle include applied force, push or pull, normal force, perpendicular surface contact, frictional force, actually opposing motion, and gravitational force due to weight. So, and the tension force through ropes or strings. So, for FBD, a free body diagram visually representing this force using arrow, either in uh, x axis or y axis, or that string F. Weight means we need to times with gravity, so 9.81. So to simplify analysis, force are broken into x and y component, resulting in equilibrium equation will get sum of fx equals to 0 and sum of fy equals to 0. So that's all from me. So I will pass you to next presenter, Ali Farhan.
Okay, hi, my name is Muhammad Ali Farhan bin Jamil and my metric number is CD240329. Okay, so for my part, I will explain about the literature review about the static of particles. Okay, so static of particle is a crucial area of engineering mechanics that focus on force and their effect on particle in equilibrium. It ensures structure and system remain stable under various force. Force equilibrium maintain a particle state of rest or a constant velocity. Free body diagram or FBD are essential tools for visualizing force and simplifying analysis by breaking them into components along coordinate axes and forming equilibrium equation. Static principles are widely applied in engineering fields such as structural, mechanical, and aerospace engineering to design a stable structure, ensure safety, and maintain control. Advances in computational tools like finite element analysis or FEA have further improved accuracy and efficiency in analyzing complex systems. Okay, so next is the real life situation of equilibrium. So these two photos are shown as an example of the situation that is related to equilibrium. So for the first photo that we collect from the around us, and we chose that as the selected and the chosen model for this topic. And for the second one is as another example that is related to this topic, which that is a traffic light, but it rarely seen in Malaysia, but it can be seen in Europe country such as America. So we choose the first picture because it easier for us to analysis the model, because we can you can do more accurate analysis for the first model. So that's all for my part. Now I will pass to the next presenter, which is Muhammad Wafiq. That's all from me.
Problem definition: hang a clothes on a string cable, depicts a 2D force system at equilibrium. So this is example 1. Problem: the diagram depicts a 2D force system in which particle A is at equilibrium. To calculate the cable tension, first we need to design a free body diagram and use the equilibrium equation. The mass for the cloth is 1 kilogram, and the value for both T1 and T2 are unknown. So the angle the angle at the applied load was assumed 13 degrees.
Hi, my name is Nasigalan Aidot and my metric number is CT240338, and I'm here to present about for the solution. So first of all, you can see here we have a FBD for the example 1, which is the meaning of FBD is free body diagram, and we refer to our case study, which is for the chapter equilibrium 2D. So as we can see here, we have a mass 1 kilogram, which is referred to the clothes of a mass that we're hanging on the middle at the tensional, and then forward that we have a 2 tensional cable, which is representative for T1 and T2 with the same angle, which is have a 30 degrees angle for both sides at the axis X, as we can see at this FBD. Alright, for the discussion part, we will analyze that our system have one key point, which is in this 2D equilibrium, where an object remain at rest under the influence of multiple forces, and that key point is included system setup, the horizontal force balance, vertical force balance, and also the tension calculation. Alright, for the system setup, as we refer to the FBD for the example 1, we can see that we put the 1 kilogram weight of mass at the middle of the tension cable, which is supported by 2 tension forces, which is respectively T1 and T2, and both of that force will apply an angle of 30 degree from Fx axis. Alright, for the force balance of horizontal, which is total cosine of Fx, we apply the formula of total cosine of Fx equal to 0, which is the T1 cosine 30 degree minus T2 cosine 30 degree equal to 0. After that, we get the T1 equal to 0.866 T2 over 0.866. After we cancelling the 0.866 by the mathematical solution, we get the T1 is equal to T2, and that is the last resulting for the Fx total cosine of Sx. Alright, for the second part, which is vertical force balance, which is total cosine of Fy equal to 0, we're using that as our formula, and then we apply the formula solution as T2 sine 30 plus T1 sine 30 minus 9.81 Newton equal to 0. Why we minus 9.81 1 Newton because there is gravitational forces that were applied at the mass. After we calculating it, we get respectively for both tensioner is 0.5 T2 plus 0.5 T1 minus and equal to 9.81 Newton, and then we transfer it as T1 because we're searching for the T1 at the Fy at the total sign of Fy. So that is mean the last calculation is T1 equal to 9.81 Newton. For the last result, the result that we get for the T2 is also 9.81 Newton. Why? Because as we referred for the total cosine of fx, the T1 is equal to T2. That means is T2 is same data or same result as a T1. So that means is T2 is also 9.81 Newton. So that's it for me. I will pass to the Faiz Rustam for the conclusion, and thank you.
Next conclusion for my report is highlight the importance of two-dimensional 2D equilibrium in maintaining a stable state with a system. The principle of equilibrium required the total force in both horizontal and vertical direction equal to zero, ensuring opposing force neutralize each other. This concept is vital in physics, engineering, as it forms the foundation for design, stable structure, machines, and systems. By understanding and applying the principle of equilibrium, we can keep objects stationary or control their motion in a predictable manner, which is crucial for safety and efficiency in practical application. Thank you.
So that's all from us. Thank you so much for your cooperation. So equilibrium is the harmony of force. Every calculation and diagrams bring clarity. In statics, balance is not just a principle; it's just a cornerstone for stability and success. Thank you.